26 over 15. Now that one's pretty messy, and having the fractions in there definitely makes it a little bit worse, but I can use this idea of one fraction divided by the other to try to simplify my slope. So I got a negative 26 over 15. Here's another one. I want to find the slope of this line. And I have two known points. Always look for some sort of indicator that that's a known point. Don't just guess that, well, I think it crosses here at about 4, because this one is in the middle of the 3 and 4. You can't tell for sure exactly what the point is. But from these 2 points, I can start at one and count over to the other. Start with the y direction. 1, 2, 3, 4, 5, 6, 7. And it was a negative 7 in the y direction, and then a positive 1, 2, 3, 4, 5, 6. So my slope here would be negative 7/6. And remember, I can also figure out what is this point, negative 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. And then what is this point? 2, 3, 0. And I want to show you one other way that we can look at figuring the slope. It's just a visual way of organizing your coordinates so that it helps you use the formula a little better. Instead of writing it to the side, I'll write them top to bottom, and then as long as I remember to take the difference in the y's first, then I can write it 7 minus 0, so this one first, this one second, and then this one first, this one second, so negative 3 minus 3. And the 7 minus 0 is 7, negative 3 minus 3 is negative 6, and remember, we like to have our negatives on top, and these two are exactly equivalent, so we can move the negative straight up to the top. So two different ways of getting the same slope. Okay, here's some for you to try. Number 1 and number 2. 1, you have 2 coordinates, find the slope, and number 2, you have a different line and use the points on the line to help you find the slope. Okay, for number 1, I'm going to actually use my visual method just to give you one more look at it. I'll line them up top to bottom, and then I'm going to say m equals 4 minus 1, so in the y direction first, and then the x direction second, 0 minus 3. So then m equals 4 minus 1 is 3, 0 minus 3 is negative 3, and 3 divided by negative 3 is a negative 1. So I have a negative 1, not a fraction anymore, but just a negative 1. For number 2, I'm going to use the counting method, because if it's graphed, that's usually going to be the quickest. Starting at one of the known points, I have to go down, so that'll be negative 1, 2, 3, 4, negative 4, and I always do the y direction first, and then in the x direction I have to go to the right, so that's positive 2 places. So it's negative 4 divided by 2. This one comes out to a negative 2 for the slope. Let's take a look at using the slope intercept form, and we have a function f of x equals 3/4 x plus 6, and remember that whole f of x, we can consider it as a y for graphing purposes. We want to find the x-intercept, and that's the place where the line crosses the x-axis, and that means if we're on the x-axis, then we have no value or a 0 for our y. So if we have a 0 for our y part, we can plug that into our formula for our line, our equation for our line. So 0 equals 3/4 x plus 6. I can subtract 6 from both sides, and I have negative 6 equals 3/4 x. And if I want to move the 3/4, I can multiply by the reciprocal, 4/3 on both sides. And on the right hand side, everything reduces, and I have x equals, and the negative 3 goes into the 6 2 times, and I have negative 8. So my x-intercept will be negative 8, 0. Now my y-intercept should be just the opposite, and it'll be somewhere on the y-axis, and if it's on the y-axis then it has no value in the x direction or a 0 in the x direction. So we can plug that in also into our formula, our equation for our line, and 3/4, instead of the x I put a 0 this time, plus 6, and that will give me a 0 for the first term, and then just y equals 6. Now if I try to find the slope, I can use this vertical format and do 0 minus 6, always the y parts first, and then the x parts, negative 8 minus 0. So I end up with negative 6 over negative 8, which simplifies to 3/4, a positive. So my slope is 3/4. Now if I come back and look at this equation that I started out with, you can see the 3/4 is here in front of the x. It's the coefficient for the x. That will always be the case if you have it solved for y. So we'll do that often. Solve for y. This is my slope right here. And then this number 6 is actually my y-intercept, and it's the y part of the ordered pair, and we call that a b. So the slope-intercept form is y equals mx plus b, and that'll be true every time you solve for y. The coefficient on your x part is your slope, and the b is the y part of your y-intercept. So we will have m for the slope, and then 0 comma b, whatever that number is, that will be our y-intercept. Okay, if we want to use that concept, we take an equation that we're given and we want to solve it for y. So we'll put negative 4x, so we can move that to the other side, and we end up with negative 3y equals negative 4x plus 6. Now I want to get the y alone, so I'll divide every term, both sides, by that negative 3. And I end up with y equals 4/3 x minus 2. Now remember, the format is called y equals mx plus b. So my m is that 4/3. My b is an ordered pair, 0 comma negative 2, and my negative 2 comes from right here. This gives me an ordered pair on my graph, so I can go ahead and graph that. 0 in the x direction, negative 2 in the y direction, so I have to move downward. And there's my point. Now I know my slope is 4/3. I can also write that as negative 4 over negative 3, because when I simplify that, negative divided by negative, it'll be a positive like I started out with. But this gives me two ways to graph: my rise over my run, and my rise over my run. And when you're first doing this, definitely pull out, write what is your slope, what is your y-intercept, and write rise over run so that you can remember from this known point, I'm going to rise 4, 1, 2, 3, 4, and run 3, 1, 2, 3. And since they're positive, I'm going in the positive direction for each. Come back to our known point, 0, negative 2, this y-intercept, and then I'm going to do negative 4 for my rise. So instead of going up, I need to go down now. 1, 2, 3, 4, and a run of negative 3, so I have to go to the left 3. Now I have 3 points on my graph. I can get my ruler and put in my graph, my line, and there I have it. So I can graph using the slope-intercept form. Let's look at another one. I want to graph this equation using the slope-intercept form. So I want it in y equals mx plus b form again. I'll write that there. Y equals mx plus b form, and it's not solved for y yet. So if I subtract 2x from both sides, I think it will be very quickly solved for y equals negative 2x plus 3. Now this is in my y equals mx plus b form, so my m is negative 2, which is the same thing as negative 2/1. And then my other way of looking at this, I want to write rise over run. My other way of looking at this will be 2 over negative 1, so that'll be my rise and my run. And then my B is going to give me an ordered pair